Hi, welcome to this course. In this topic, you will understand the importance of problem solving before you begin learning the programming languages. There will be knowledge checks in between to determine your understanding over the facts learned so far. You will also be provided with a self assessment at the end, followed by a practice session to qualify yourself for the next topic. Only upon completion of both the topic and self assessment, you would be enabled with the next topic. You will need approximately 20 to 25 minutes to complete this topic. Wishing you a very happy learning through BitLabs. Before we dive into the core concepts as listed in the learning objectives, let us first understand why problem solving is so important when it comes to learning programming language. Problem solving is more critical and important even before you start programming. A programmer without a good problem solving skills would make just a coder and not an efficient engineer. Proactive problem solvers develop solutions and make decisions on their own without getting stuck. And this drives innovation and increased efficiency in their performance. A survey shows that only 62% of job seekers are with good problem solving skills. In real life, when we come face to face with problems, sometimes we solve it easily and sometimes we take extra time. Well, that depends on the type of the problem, which could either be a well defined problem or an ill defined problem. Click each side of the image to know more. A problem is ill defined when it does not have a clear, definite, and well formed path or sufficient information to reach the goal. Such problems have more than one possible answer. For example, as a job seeker, you might be wondering about getting a dream job, or as a traveler, you might be wondering what could be the best and safest route to reach your destination. A problem is well defined when it has a clear, definite, and well formed path and sufficient information to reach the goal. For example, imagine you are accidentally locked up inside a dark room where there are no windows and you're already scared of darkness. The only way to get rid of this panicking situation is turning on the lights to make the room bright. Before we move on to the next screen, let us quickly check your understanding on what we have seen so far. There are no hard and fast rules to solve any problems. However, understanding some of the basic problem solving principles and techniques can help to arrive at a possible solution. Click each principle to know more. To understand your problems, you must first identify your goal, ask questions, and finally restate the problem. Let us look at them in detail. Identify your goal is nothing but the expected end result that you're trying to find. Ask questions. Make sure you ask the right question, as this is one of the problem solving techniques. Most of the times, we think about a problem inside our head, but never put an effort to write it down, which can deviate us from asking right questions. It is highly recommended to write down a good and detailed question to understand what your problem is. Remember, a properly formulated question or problem often yields answer. And finally, restate the problem with all the answers that you got through asking tons of questions. To make a plan, follow these steps. Observe for a pattern, draw a picture, break down the bigger problem into smaller parts, and be creative. When it comes to being creative, do a lateral thinking by generating ideas through creative approach that may not be obtainable by using traditional logic. This approach involves listing all the assumptions, visualizing the approach, and rewriting the question. Execute the plan. Implement the action plan to address the root cause in order to reach an optimal goal. Optimize, finding the best solution from all possible options. Before we move on to the next screen, let us quickly check your understanding on what we have seen so far. Let us discuss an example on how to apply the problem-solving technique in real-life scenario with one of the examples that we had discussed earlier. Assume you are a cricket lover wondering what could be Virat Kohli's score in his next match. Let us recall the problem-solving principles to understand this problem. Identify your goal. This is guessing Virat Kohli's score in the next match. Now, ask questions such as who is the opponent? What is the match format? What is his position in the batting lineup? What is the pitch condition? What are the average highest runs scored in that ground? How was his performance with the observed conditions in the last few matches? The possible answers for these questions are displayed here. Now, restate the problem with all these answers. You will be able to figure out a pattern and arrive at a possible solution. Hence, in this example, if Virat Kohli is going to play against the same team in the same ground, then he has all possibilities to score minimum of 50 runs considering his match history that is concluded based on the questions that were rightly asked in analyzing this data. Now, let us look at some of the tools used in solving problems programmatically. These includes algorithm, pseudocode, flowcharts, and program. Click each tab to know more. An algorithm is a set of steps to accomplish a task. It puts the science to computer science. We do use algorithms in day-to-day life. For example, Google Directions. It is a step-by-step instructions to reach your destination. These algorithms can be expressed diagrammatically using flowcharts. Pseudocode is a text-based algorithm to instruct a computer to perform various tasks. It is expressed in an informal language which is usually English. For example, let us look at the pseudocode for the scenario where students log into Flipkart account. So the pseudocode can be written as go to www.flipkart.com, enter email ID and password, and click on Login button. There's a saying that a picture is worth 1,000 words. Likewise, in programming, a solution can be well expressed using flowcharts. These flowcharts use various symbols to depict the data flow such as start or stop, arrow, input or output, process, decision, and loop. Let us look at them in detail. Start or stop. This is a flowchart terminator used at the beginning and end of the algorithm to show start and end of the program. Arrow. This is a line connector that shows the logical flow of the process. Input or output. This is a parallelogram symbol that is used for denoting program inputs and outputs. Process. This is a rectangular symbol which indicates logic blocks with instructions. Decision. This is a diamond-shaped symbol that stands for decision statements in a program where answer is either yes or no. Looping. This helps in repeating the process multiple times. Let us look at an example of a flowchart. When you go to your favorite burger outlet to place an order for burger, you will be provided with more options like fries or drinks to add to your list. If you choose only to buy a burger, then you would say no and proceed to pay only for the burger. But if you choose to buy the fries and drinks along with the burger, then you say yes, order each item individually, and then proceed to pay for all three items. Thus, a flowchart shows the sequence of instructions from start till end in a single diagram. A program is a set of instructions in the form of code developed using a programming language to solve a problem. Before we move on to the next screen, let us quickly check your understanding on what we have seen so far. We have come to the end of this topic. Let us recap the concepts that we have learned so far. Programming language is a formal language that is used to instruct a computer to perform various tasks to achieve an output, and these are primarily meant to solve problems. There are two types of problem: a well-defined problem and an ill-defined problem. There are some general problem-solving principles and techniques to solve any kind of problems. Tools that are used in programming to solve problems are algorithm, pseudocode, flowcharts, and program. Welcome to the self-assessment section. This short practice activity is to test your understanding of the concepts covered in this topic. A set of 4 simple activities are provided to you. Perform the necessary steps to solve the problems. Your topic would be considered as completed only after you complete the test. Good luck! Click Next to begin your test. Congratulations! You have completed this topic successfully. Kindly hit the close button on your window or click the exit button on the screen to safely exit this topic. You're also provided with retake test and revisit topic options. Thank you. See you in the next topic.